Before we dive into one of the most shocking reversals in tank warfare history, do me a favor, hit that like button right now, smash that subscribe button, and drop a comment telling me where you're watching from. Are you in Berlin, London, Tokyo, Los Angeles? I want to know. September 19th, 1944. Arracourt, France. Morning fog blankets the rolling countryside of Lorraine. Through the mist, the grinding roar of engines announces the arrival of death. 45 factory-fresh Panther tanks, the most feared armor on the Western Front. Their 75 mm guns can penetrate a Sherman from 2,000 meters. Their sloped frontal armor is virtually impenetrable. The American tankers waiting in ambush shouldn't stand a chance. But in the next 11 days, something impossible happens. The Panthers, technologically superior in every measurable way, are systematically destroyed. Not by luck. Not by numbers alone. By speed. This is the story of how American tank crews overcame one of the most significant technological disadvantages in military history. It's about the power traverse system and gyrostabilizer, two innovations that transformed the M4 Sherman from an underdog into a weapon that terrified German tank commanders. The stakes couldn't have been higher. By September 1944, the Allies were racing toward Germany's industrial heartland. General George Patton's Third Army had broken through France, but Hitler had ordered a desperate counterattack, recapture the town of Lunéville, destroy the American bridgehead across the Moselle River, and stop Patton's advance cold. The German 5th Panzer Army deployed 262 tanks and assault guns, including over 100 Panthers, against Combat Command A of the 4th Armored Division. The Panthers mounted high-velocity 75 mm guns that could kill a Sherman at extreme range. Their frontal armor was 140 mm thick when angled, effectively impervious to the Sherman's gun beyond 1,000 yards. The Panther weighed 43 tons to the Sherman's 33, had better optics, and represented the cutting edge of German tank design. On paper, this should have been a massacre. Instead, over 11 days of intense combat, the Americans destroyed or disabled 200 German tanks while losing only 48 of their own. Combat Command A shattered 2 elite panzer brigades and broke the back of Germany's counteroffensive. Oh. The answer lies in two American innovations that the Germans not only failed to develop, they couldn't even copy when they captured them. And in the courage of tank crews who learned to trust technology that seemed almost magical in its capabilities. To understand the miracle at Arracourt, we need to go back to 1940, when American tank development was years behind Germany's. When Hitler's panzers smashed through France in 6 weeks, the United States Army was equipped with the M2A1 light tank, a training vehicle armed with a pathetic 37 mm gun. American military doctrine still viewed tanks primarily as infantry support weapons, not breakthrough vehicles. While German theorist Heinz Guderian had developed the revolutionary concept of massed armored spearheads supported by air power and followed by infantry, the dreaded blitzkrieg, American thinking remained rooted in World War I static warfare. The fall of France shocked American military planners into action. In July 1940, the War Department authorized development of a new medium tank and organized the 1st Armored Divisions. The result was the M3 Grant, a stopgap design with a 75 mm gun mounted in the hull, giving it a high profile and limited traverse. It was better than nothing, but everyone knew it was temporary. The real solution emerged in February 1942, the M4 Sherman. Named after Civil War General William Tecumseh Sherman, this 33-ton medium tank would become the most produced Allied tank of the war. Between 1942 and 1945, American factories churned out more than 49,000 Shermans, a staggering testament to American industrial might. They equipped not just U.S. forces but also British, Canadian, Free French, Polish, Chinese, and Soviet units. Over 21,000 went to Allied forces through Lend-Lease. The Sherman was designed for mass production and reliability. It used a proven chassis, a reliable 500 horsepower Ford GAA V8 engine, and relatively simple maintenance procedures. Crews loved that it could be repaired on the battlefield, often while under fire. It had a top speed of 26 miles per hour and a range of 160 miles, exceptional operational mobility. But its armament was mediocre. The original 75 mm M3 gun was adequate against early Panzer III and IV tanks, but by 1943, it was obsolete. Sherman armor maxed out at 75 mm thick, decent protection against small arms and artillery fragments, but vulnerable to German anti-tank weapons. The tank's profile was tall, making it easy to spot and hit. When the Sherman first saw combat in North Africa in October 1942 with British forces, it performed adequately. But by the time of the Normandy invasion in June 1944, German tank development had leaped ahead. The Panther, introduced in 1943, mounted a high-velocity 75 mm gun with a muzzle velocity of 936 meters per second, compared to 384 meters per second for the Sherman's original gun. The Panther's frontal armor was effectively 140 millimeters thick due to extreme sloping. It could kill a Sherman from 2,000 meters. A Sherman could only penetrate a Panther's frontal armor at point-blank range, if the crew was lucky and hit the mantlet or a weak point. The Tiger I was even worse, 68 tons, armed with the legendary 88 mm gun, frontal armor up to 120 mm thick. Tiger IIs arriving in late 1944 were virtual fortresses. British tank crews gave the Sherman a grim nickname, the Ronson, after the cigarette lighter advertised with the slogan, "Lights first every time." The implication was horrifying. Shermans supposedly burst into flames from a single hit. Yet despite these fearsome German machines, despite technological inferiority in firepower and armor, American Sherman crews would achieve something remarkable. They would win. Decisively. Repeatedly. The secret wasn't bigger guns or thicker armor. It was two technologies that American engineers had perfected and German engineers couldn't match: the 360-degree power traverse system and the vertical gyrostabilizer. Together, these innovations would give American tank crews a lethal advantage: the ability to shoot first, shoot accurately, and shoot while moving. And in tank combat, getting the first hit. By September 1944, American tank crews in Europe faced a terrifying reality. They were outgunned, out-armored, and, on paper, outclassed. Lieutenant Colonel Creighton Abrams, commander of the 37th Tank Battalion, knew the math cold. His men faced German Panthers that could destroy their Shermans from distances where they couldn't even fire back effectively. The psychological impact was devastating. One Sherman commander later recalled, "You'd see a Panther hull down on a ridge, 2,000 yards out. You'd know damn well he could see you. And you'd know that if he fired, you were dead. But your 75 millimeters couldn't scratch his glassy plate at that range. So you'd have to button up, pray, and try to maneuver. And hope you found his flank before he found yours." The statistics were brutal. In Normandy, the U.S. First Army conducted a study of tank versus tank combat. They found that Sherman 75 mm guns could only penetrate Panther frontal armor at 200 yards or less, point-blank range. Even at 500 yards, penetration was unreliable. Meanwhile, the Panther's gun could punch through a Sherman's frontal armor from 2,000 yards and its side armor from even greater distances. The kill ratio was sobering. Some German units claimed 5 or 6 Shermans destroyed for every Panther lost. Tiger tanks were even more fearsome. One Tiger I, commanded by SS Oberscharführer Michael Wittmann, had destroyed over 130 Allied tanks and self-propelled guns. German tank ace Otto Carius wrote in his memoir, "The Americans would come at us in waves. We'd knock out the first, the second, the third. They'd keep coming. Eventually, sheer numbers would overwhelm us." But it wasn't just about the guns and armor. The psychological impact of facing superior technology was crushing morale. A corporal from the 2nd Armored Division wrote home, "The Panther is 50% heavier and carries a gun that'll go through us like tissue paper. When we see one, we're supposed to get 4 or 5 Shermans to gang up on it, one for bait, the others to flank. But here's the thing, that means 3 or 4 of us are gonna burn, so one might get through. How do you volunteer to be bait?" The infamous Ronson nickname wasn't entirely fair. Almost all World War II tanks used gasoline and could burn, but Shermans did have a real problem. Early models stored ammunition in unprotected sponsons on the sides of the hull. A penetrating hit would often ignite the ammunition, causing catastrophic explosions that blew turrets clean off. Crews called it brewing up. The survival rate for crews in burning tanks was appalling. Engineers tried to fix it. They added applique armor plates, extra steel welded onto the hull, adding another inch of protection. They redesigned ammunition storage, implementing wet stowage, where ammunition was bathed in water glycerin solution to prevent ignition. They added armor around ammo racks. These modifications helped, but couldn't overcome the fundamental problem. The Sherman's gun was too weak and its armor was too thin. By late 1944, the U.S. Army was finally fielding the M4A3E8 Easy 8 Sherman with the 76mm high-velocity gun, an improvement that could at least threaten Panthers for medium range. But production was limited. Most Sherman crews at Arracourt in September 1944 still had the old 75mm gun. The Germans, meanwhile, were not sitting still. The Panther had its own problems. It was over-engineered, mechanically unreliable, and difficult to maintain. Its interleaved road wheels, overlapping wheels on the suspension, would pack with mud and freeze solid in winter, immobilizing the tank. Its transmission was fragile. German crews joke bitterly that they lost more Panthers to breakdowns than to enemy fire. But when a Panther was working, it was deadly. Its 75mm gun had phenomenal range and accuracy. German optics were superior. Their telescopic sights had specially coated lenses that provided brighter, clearer images. And German tank crews were often veterans with years of combat experience on the Eastern Front against Soviet armor. The tactical situation at Arracourt made everything worse. Combat Command A of the 4th Armored Division was isolated. They'd advanced so fast that follow-on forces couldn't keep up. They held a salient around the town of Arracourt with an outpost line, a thin defensive perimeter of infantry, engineers, and tanks. When German scouts reported this exposed American position, 5th Panzer Army saw an opportunity to cut off and destroy an entire combat command. The Germans assembled an overwhelming force, the 111th and 113th Panzer Brigades, each with 45 Panzer IVs and 45 brand-new Panthers fresh from the factory, plus elements of the veteran 11th Panzer Division, plus self-propelled assault guns. In total, 262 armored vehicles. Combat Command A had perhaps 60 Shermans and a handful of M18 Hellcat tank destroyers. The Germans expected to annihilate them in a day. Instead, they were about to learn a painful lesson about American innovation and crew training that would cost them 2 entire Panzer brigades. The secret weapon that would save Combat Command A wasn't visible from outside the tank. It was hidden inside the turret, in 2 revolutionary systems that American engineers had perfected and German engineers had failed to develop: the power traverse and the gyrostabilizer. Let's start with power traverse, the ability to rotate a tank turret using electric or hydraulic power rather than hand cranks. German tanks used a complicated system that drew power from the engine through the transmission. This meant the engine had to be running at high RPM to get full turret rotation speed. Even then, it was slow. A Panther took about 55 seconds to rotate its turret 360 degrees at optimal speed. A Tiger I took about 60 seconds. And these were only achievable if the engine was running hot and the power takeoff system was functioning properly, which it often wasn't. Worse, the German system was imprecise. Gunners used it to get the gun pointed in the general direction of a target, then had to fine aim using manual handwheels. This was slow, tedious, and required the tank to be stationary. American designers took a different approach. The Sherman's turret was driven by an independent electric motor powering a hydraulic system, or in some models, a direct electric drive. The system, manufactured primarily by Oil Gear Company, was incredibly precise and fast. A Sherman could rotate its turret 360 degrees in just 15 seconds, nearly 4 times faster than a Panther. More importantly, the power traverse was precise enough for fine aiming. The gunner controlled it with a foot pedal or hand grip, allowing smooth, exact movements. The tank commander had an override control, meaning he could physically control the turret from his position, spot a target, swing the gun onto it, and direct the gunner to fire, all in seconds. Brigadier General Albin Irzik, who commanded the 8th Tank Battalion in the 4th Armored Division, later wrote about this advantage. By means of the 360-degree power turret traverse with which all our tanks are equipped, a tank gunner is able to swing his gun in any direction in a second or a fraction thereof. The average American tank gunner can lay on a German tank, is able to get the first round off, and can usually score the first hit. Irzik described an incident where a Tiger tank lay hidden in ambush, fired first at advancing Shermans, and missed. That single mistake was fatal. American tanks maneuvered about it and with their rapid fire destroyed the German tank, he wrote. The Americans got off 3 or 4 rounds for every one the German fired. The psychological impact was devastating for German crews. They were accustomed to tactical superiority, better guns, better armor, veteran crews. Suddenly, American tanks were spinning their turrets with inhuman speed, putting multiple rounds downrange before German gunners could even track their targets. But power traverse was only half the equation. The other half was even more revolutionary: the vertical gyrostabilizer. Every Sherman, except those armed with 105mm howitzers, had a Westinghouse gyrostabilizer that kept the main gun steady in elevation while the tank was moving. It used a gyroscope and hydraulic power pulled from the turret drive system to compensate for the tank's motion. This technology was so advanced that Germany never successfully fielded it during the war. They simply couldn't engineer a system that was reliable and compact enough to fit in a tank turret. The stabilizer worked like this: a gyroscope sensed the tank's vertical motion, bouncing over terrain, tilting on slopes. The hydraulic system automatically adjusted the gun's elevation to compensate, keeping it pointed at the same spot regardless of how the hull was moving. The gunner could keep his sight on target while the tank rolled over shell holes, ditches, and debris. Now, the stabilizer wasn't perfect. It only worked in the vertical plane, not horizontal. It was most effective at speeds up to 10 or 15 miles per hour. And many American crews, especially replacement crews who hadn't trained with it extensively, turned it off because they didn't understand how to use it properly. But crews who mastered it, like the veterans of the 4th Armored Division, had a game-changing advantage. They could fire accurately while moving. Not at long range, stabilizer or not, firing a 75mm gun from a moving tank at 2,000 yards wasn't going to hit anything. But at combat ranges of 500 to 1,000 yards, a Sherman with its stabilizer engaged could shoot on the move with reasonable accuracy. More importantly, the stabilizer allowed incredibly fast engagement when stopping. A German tank commander spotting an enemy had to halt the tank, wait for it to settle, manually traverse the turret to aim, fine adjust with handwheels, range the target, and fire. This took precious seconds, often 20 to 30 seconds from first sighting to first shot. A Sherman crew could engage stabilizer while moving, spot target, swing turret with power traverse while gunner kept sight on target, issue a fire command, and the gunner would simply disengage the stabilizer and fire. The gun was already aimed. The process took 3 to 5 seconds. In tank combat, where the first hit often decides the outcome, this was decisive. The Imperial War Museum later analyzed this advantage. They noted that a Sherman could rotate its turret in 17 seconds at full speed. A Panzer IV took 26 seconds. A Tiger or Panther took nearly a minute. So that's a very significant difference, which means you're much more likely to be able to maneuver your turret to get in the first shot or first several shots before that Tiger or before that Panther can traverse its turret to get a shot back at you. There was another advantage: volume of fire. American tankers discovered they could suppress German tanks even when they couldn't penetrate their armor. If you hit a Panther's frontal armor with successive 75mm rounds, even if they didn't penetrate, the impacts would force the German commander to button up, close his hatch, and rely solely on periscopes. This reduced his situational awareness and combat effectiveness. Hit the periscope itself and you'd effectively blind him. Hit a track or road wheel and you'd mobility kill the tank. Hit the turret ring or mantlet and you might jam the turret. And if a German tank was hit, even if it didn't penetrate, there was a statistical probability the crew would bail out. Sherman crews learned to exploit this. One veteran recalled, "We'd hit them with everything we had. 3, 4, 5 rounds as fast as we could load. The impacts would sound like hammer blows. We couldn't kill them from the front, but we could scare them. And scared tankers make mistakes. They panic, expose their flanks, or just abandon the tank." The combination of fast turret traverse and gyrostabilization created a system effect. American tanks could spot, engage, and fire faster than their opponents. They could put more rounds downrange per minute. They could shoot accurately from short halts or even while moving slowly. And they could maneuver aggressively while maintaining fire. When Captain Jimmy Leach of B Company, 37th Tank Battalion, assembled his platoon commanders at Arracourt and pointed out nearby Panthers, his orders were simple and devastating: "Mount tanks now. I want you to move guns A-blazing, in line formation with all guns A-blazing." The Germans had never seen anything like it. American tanks advancing at speed, turret spinning, guns firing continuously. It violated every assumption of how tank combat worked. And it worked. September 19th, 1944. 8 o'clock hours. The German 113th Panzer Brigade attacked through thick morning fog. Company-sized elements penetrated Combat Command A's thin outpost line. Panthers emerged from the mist like ghosts, massive, angular, terrifying. Their 75mm guns swiveled, searching for targets. This should have been their moment of triumph. Instead, it became a slaughter. The fog that concealed the German advance also concealed American positions. Sherman crews, using their superior power traverse, could spin their turrets to track enemy movement through brief gaps in the fog. When Panthers exposed their thinner side armor, only 40 to 45 millimeters compared to 110 millimeters frontal, the Americans fired. 2 platoons of tank destroyers and a medium tank company engaged the German armor in a running fight that extended into the vicinity of CCA headquarters. Shermans flanked and knocked out 11 Panthers using the fog as cover. The Germans, lacking proper reconnaissance units, advanced blindly, exposing their vulnerable sides to American ambush positions. By mid-morning, the fog began to lift. This should have helped the Germans. Their superior optics and long-range guns should have dominated in clear weather. But now the Americans had a new advantage: air support. P-47 Thunderbolts from the 19 Tactical Air Command roared overhead. Major Bazooka Charlie Carpenter, an Army observation pilot who'd mounted bazookas on his tiny Piper L-4 Cub, dived repeatedly through German ground fire, attacking Panthers with rocket after rocket. One witness described his tiny aircraft like a mosquito attacking an elephant, but the psychological effect was enormous. German tanks, unable to elevate their guns high enough to shoot back effectively, could only button up and pray. The coordinated attacks, Shermans engaging from advantageous positions, artillery fire directed by forward observers, and constant airstrikes, devastated the 113th Panzer Brigade. By day's end, they'd lost 37 tanks and withdrew in confusion. September 20th brought another German attack. This time, Company C of the 37th Tank Battalion, under Captain Kenneth Lamison, engaged Panthers along the Metz-Strasbourg road. In the initial contact through dissipating fog, Lamison's crews disabled 3 Panthers before the Germans could effectively return fire. Then came the moment that would define the battle. 8 Panthers appeared on a ridgeline, silhouetted against the morning sky. Lamison's platoon arrived at their position approximately 3 minutes before the Germans came into view. 3 minutes. In that tiny window, the American crews used their power traverse to aim their guns, stabilizers engaged, ready. When the Panthers appeared, Lamison's tanks got set and knocked out 4 German tanks before they could return fire. Then they withdrew over the crest of the ridge, using terrain for protection, moved south a short distance, reappeared from a different angle, and finished off the remaining 4 Panthers. 10 minutes. 8 Panthers destroyed. 0 American casualties. This engagement became legendary in the 4th Armored Division. It perfectly demonstrated the American advantage: rapid engagement, accurate fire, aggressive maneuver, and the exploitation of momentary opportunities. The Germans, with their slow turret traverse and lack of stabilization, couldn't react fast enough. Throughout September 19th to 22nd, the pattern repeated. German tanks would attack. American crews would use their technological advantages to engage first, fire more rapidly, and maneuver aggressively. The Germans lost tanks by the dozen. Lieutenant Colonel Creighton Abrams, whose name would later be given to the M1 Abrams tank, orchestrated his battalion with aggressive precision. On September 22nd, when the 111th Panzer Brigade mounted a major attack on the town of Juvilliers, Abrams coordinated direct fire from his tanks, indirect artillery fire from CCA's guns, and airstrikes from P-47s in a devastating combined arms assault. His tanks advanced firing, using their stabilizers to maintain accuracy while moving. The power traverse let them engage multiple targets in rapid succession. One company commander reported his tanks fired so rapidly that German crews abandoned their Panthers and fled rather than face the onslaught. By September 25th, the German counteroffensive had collapsed. 5th Panzer Army's after-action reports make grim reading. Of the 262 tanks and assault guns they'd committed to battle, only 62 were still operational. The 111th and 113th Panzer Brigades were effectively destroyed as cohesive fighting units. German commanders reported, the American tanks moved with incredible speed. Their guns traversed faster than ours. They seemed to fire at will while moving. Our crews couldn't match their rate of fire. One captured German tank commander told interrogators, "We would spot an American Sherman at perhaps 1,200 meters. Excellent range for our gun. We would begin traverse to engage. But before we could complete the traverse and fire, the American would have his turret on us and would fire 3, sometimes 4 rounds. The impacts were like hammers. We couldn't see. The tank would shake. By the time we fired, he would have moved. We were told the Sherman was inferior. But it killed us just the same." The statistics tell the story. Combat Command A reported 48 total tank losses during the 11 days of combat. The Germans lost approximately 200 tanks destroyed or disabled, more than a 4-to-1 kill ratio in favor of the inferior Sherman. General George Patton visited Arracourt during the fighting. Standing beside a destroyed Panther, he told General John Tigerjack Wood, "This is the finest armored fighting I've seen. These boys are giving the Germans a lesson in how to use tanks." The psychological impact on German tank crews was profound. After Arracourt, captured documents revealed German commanders warning their crews about American tank tactics. They emphasized the need to engage from maximum range, to avoid close combat where American fire rate and turret speed gave insurmountable advantages, and to never, under any circumstances, allow American tanks to close within 500 meters. But American doctrine was evolving to exploit this fear. Tank commanders learned to advance aggressively, use terrain to close the distance, and rely on their technological advantages in close combat. The Sherman, which began the war as an underdog, was becoming a weapon German crews genuinely feared. The Battle of Arracourt had another critical impact. It vindicated American tank design philosophy. Critics had argued for years that the U.S. should abandon the Sherman and produce heavier, more powerful tanks like the M26 Pershing. But Arracourt proved that reliability, speed, crew training, and technological innovation could overcome raw firepower and armor. General Dwight Eisenhower cited Arracourt in discussions about tank production. The battle demonstrated that American tanks, properly employed with combined arms tactics and superior crew training, could defeat technically superior German armor. This influenced decisions to continue Sherman production rather than divert resources to newer designs. Perhaps most importantly, Arracourt secured Patton's bridgehead across the Moselle River. The German counteroffensive had been designed to push the Americans back, buying time for Germany to fortify the Siegfried Line. Instead, Third Army held its ground and prepared to drive deeper into Germany. When Patton launched his Ardennes offensive in November 1944, it was from positions secured at Arracourt. The battle also provided crucial experience for American tankers who would later face similar challenges in the Battle of the Bulge. The lessons learned at Arracourt, aggressive maneuver, rapid engagement, combined arms coordination, would prove vital in December when Germany launched its last great offensive. The Battle of Arracourt demonstrated a truth that echoes through military history. Technological superiority doesn't guarantee victory. The side that innovates, adapts, and executes superior tactics often prevails despite material disadvantages. The Sherman tank's power traverse and gyrostabilizer weren't the most glamorous innovations of World War II. They didn't make headlines like atomic bombs or jet fighters. But they exemplified a uniquely American approach to warfare, engineering practical solutions to tactical problems, manufacturing them at scale, and training crews to exploit their advantages. Consider the engineering philosophy behind these systems. German tank designers prioritized armor thickness and gun size, measurable metrics that impressed on paper and looked intimidating on the battlefield. They built technological marvels like the Tiger II, 68 tons, 185 millimeters of frontal armor, an 88 millimeters gun that could destroy any Allied tank at ridiculous ranges. But those Tigers were over-engineered nightmares. They broke down constantly. Their interleaved road wheels required hours of maintenance. Their fuel consumption was so high that some Tigers had an operational range of just 2.5 hours. They were too heavy for most bridges, requiring special loading procedures for rail transport. Production was slow and expensive. American designers made different choices. They prioritized reliability over raw power, speed over armor thickness, ease of maintenance over engineering complexity. The result was a tank that worked. Every time. Anywhere. The Sherman could run for days without major maintenance. It could be repaired in field conditions by crew members with basic tools. It could cross bridges that would collapse under a Panther. It could travel hundreds of miles on internal fuel supplies. And crucially, American factories could produce them faster than Germany could destroy them. There's a famous anecdote from after the war. A German engineer was shown a captured Sherman with its power traverse and stabilizer systems exposed. After examining it for several minutes, he reportedly said, "We could have built something similar. But it would have required precision manufacturing at a scale our industry couldn't sustain. You Americans made complex engineering look simple. That's the genius of it." This philosophy, practical innovation over theoretical perfection, became a hallmark of American military technology. The M1 Garand rifle, the P-51 Mustang fighter, the Liberty ship, the proximity fuse, all followed the same principle. Design something that works reliably, manufacture it in quantity, and trust your personnel to use it effectively. The human element was crucial. The 4th Armored Division's success at Arracourt wasn't just about technology. It was about training, leadership, and tactical flexibility. Lieutenant Colonel Creighton Abrams exemplified this approach. He understood his equipment's strengths and designed tactics to exploit them. He trained his crews relentlessly in rapid engagement drills. He emphasized aggressive maneuver and combined arms coordination. When the battle came, his tankers knew exactly what to do. Captain Jimmy Leach's order, "Move guns a-blazing," captured this perfectly. American doctrine had evolved to emphasize offensive action, rapid fire, and overwhelming force at the point of contact. German doctrine, built on the defensive superiority of their heavy tanks, couldn't adapt. This adaptability proved decisive. When faced with superior German armor, American commanders didn't retreat or wait for better equipment. They innovated tactically. They used terrain to close the range. They flanked enemy positions. They called in artillery and air support. They coordinated multiple tank platoons to attack simultaneously from different angles. The Germans, despite their tactical experience and superior technology, were doctrinally inflexible. They attacked piecemeal rather than concentrating their forces. They failed to provide adequate reconnaissance. They didn't coordinate infantry, armor, and artillery effectively. And crucially, their inexperienced crews, the 111th and 113th Panzer Brigades were newly formed units fresh from training, couldn't match the veteran American tankers in small unit initiative and adaptation. The legacy of the power traverse and stabilizer extended far beyond World War II. These innovations became standard features on every American tank design that followed. The M26 Pershing, M46 Patton, M47, M48, M60, all featured improved versions of these systems. By the time the M1 Abrams entered service in 1980, stabilization technology had advanced to include full two-axis stabilization, laser rangefinders, ballistic computers, and thermal imaging. But the fundamental principle remained: American tanks should be able to shoot first, shoot accurately, and shoot while moving. Modern tank combat has validated this philosophy repeatedly. In Operation Desert Storm, M1 Abrams tanks with their advanced stabilization and fire control systems engaged Iraqi T-72s at ranges and speeds the Iraqis couldn't match. In one famous engagement, the Battle of 73 Easting, American tanks destroyed Iraqi armor while moving at 30 miles per hour in a sandstorm. The Iraqis never knew what hit them. This is the direct descendant of the technology that won at Arracourt. But perhaps the most important legacy is philosophical. Arracourt taught that wars aren't won by having the best equipment. They're won by having good enough equipment, produced in sufficient quantity, operated by well-trained personnel, and employed with innovative tactics. The Sherman was never the best tank of World War II. The Panther had a better gun and better armor. The T-34 had better sloped armor and wider tracks for mobility. The Tiger had intimidating firepower. But the Sherman had something more important. It was reliable, maintainable, producible at scale, and equipped with innovations that gave crews a decisive tactical advantage. There's a broader lesson here about innovation itself. The Germans pursued technological perfection: bigger guns, thicker armor, more powerful engines. This led to impressive machines that performed spectacularly under ideal conditions. But ideal conditions rarely exist in war. When Tigers broke down, they were often abandoned because they couldn't be recovered or repaired. When Panthers ran out of fuel, they became immobile pillboxes. Americans pursued practical effectiveness. They built tanks that worked in muddy French fields, desert sandstorms, Italian mountains, and frozen Belgian forests. They engineered systems that mechanics could fix with basic tools. They designed production processes that could train workers quickly and maintain quality at high volume. This approach won the war. Not just in tanks, but in ships, planes, trucks, weapons, and supplies. American industry outproduced the Axis powers by staggering margins. And American engineers ensured that what was produced actually worked on the battlefield. For modern innovators, whether in military technology, business, or any other field, Arracourt offers timeless lessons. First, practical beats perfect. The stabilizer and power traverse weren't revolutionary breakthroughs. They were careful engineering solutions to specific tactical problems. But they worked reliably under combat conditions, and that made all the difference. Second, speed matters more than power. The Sherman couldn't penetrate a Panther frontally, but it could get the first shot off 3 times faster. In combat, that tempo advantage was decisive. This principle applies broadly. Whether you're developing software, launching products, or competing in business, the ability to iterate and act faster than competitors often trumps raw capability. Third, train your people. Technology alone didn't win at Arracourt. Well-trained crews who understood their equipment strengths and knew how to exploit them made the difference. The same stabilizer system in the hands of poorly trained crews was useless. In veteran hands, it was devastating. Fourth, adapt or die. German doctrine couldn't evolve fast enough to counter American tactical innovations. Their commanders kept using the same tactics that had worked on the Eastern Front, but American combined arms coordination, tanks, artillery, infantry, and air power working together, proved superior. Fifth, production is strategy. America's ability to manufacture 49,000 Shermans meant that losing tanks was acceptable. Every German Panther lost was irreplaceable. Every Sherman destroyed was replaced within days. Strategic depth matters as much as tactical excellence. The men who fought at Arracourt embodied these principles. They were mostly citizen soldiers, factory workers, farmers, students, who'd been drafted and trained to operate complex machinery under lethal conditions. They faced an enemy with superior equipment and often greater experience. But they had confidence in their tools, trust in their training, and leaders who knew how to win. Lieutenant Colonel Creighton Abrams went on to become Army Chief of Staff during the Vietnam War. The M1 main battle tank that bears his name embodies the same philosophy he demonstrated at Arracourt: mobility, firepower, and advanced technology combined with superior crew training. Captain Jimmy Leach survived the war and returned to civilian life, but his order to advance, guns a-blazing, entered armored warfare doctrine. Aggressive maneuver combined with overwhelming firepower at close range became standard American tactics. The veterans of the 4th Armored Division rarely boasted about their accomplishments. When asked about Arracourt, most would shrug and say they'd just done their jobs. But the numbers speak for themselves. They destroyed 2 German panzer brigades, killed or captured thousands of enemy soldiers, and stopped a major counteroffensive cold. They did this while suffering fewer casualties than they inflicted, rare in tank warfare, where both sides usually pay heavily. They achieved it not because they had better tanks, but because they had better systems, better training, and better tactics. In the decades since World War II, military analysts have studied Arracourt extensively. It's taught at West Point, the Armor School at Fort Benning, and military academies worldwide. The battle demonstrates how technological innovation, when properly exploited, can overcome material disadvantages. It also demonstrates the importance of investing in seemingly minor improvements. The power traverse and stabilizer didn't look revolutionary. They didn't promise to win battles single-handedly. But they gave American crews a fraction of a second advantage in target acquisition and engagement, and that fraction of a second saved thousands of lives. Today, as military forces around the world develop next-generation tanks, the lessons of Arracourt remain relevant. The Russian T-14 Armata boasts impressive armor and firepower. The German Leopard 2A7 has exceptional protection. The British Challenger 3 features a new 120mm gun. But American M1A2 Abrams tanks continue to emphasize fire control systems, stabilization, and crew ergonomics, the same priorities that won at Arracourt 79 years ago. The tank itself has evolved dramatically. Modern main battle tanks have composite armor, smoothbore guns firing kinetic penetrators, computerized fire control, and thermal imaging. They can engage targets at 3 kilometers while moving at full speed over rough terrain. The technology would seem like science fiction to the Sherman crews of 1944. But the principle remains: get the first shot, make it count, and keep shooting faster than the enemy can respond. That's what won at Arracourt. That's what wins today. So here's what you should take away from this story. Innovation doesn't always mean revolutionary breakthroughs. Sometimes it means engineering practical solutions to specific problems. Sometimes it means manufacturing good enough equipment in sufficient quantity. Sometimes it means training people so well that they can exploit small advantages to achieve decisive results. The Sherman tank wasn't perfect. It was just good enough, and that made all the difference. The next time someone tells you that you need the latest, greatest, most powerful solution to win, remember the Sherman crews at Arracourt. Remember that they faced Panthers and Tigers with inferior guns and thinner armor. Remember that they won anyway, because they had speed, training, and innovation on their side. Remember that sometimes, shooting first matters more than shooting hardest. And if you enjoyed this deep dive into one of World War II's most fascinating tank battles, do me a favor right now. Smash that like button, hit subscribe if you haven't already, and drop a comment telling me what military history topic you want to see next. Should we cover the Battle of 73 Easting? The development of the M1 Abrams? Naval innovations in the Pacific? Let me know. Thanks for watching. I'll see you in the next one.